Hi guys. I saw that some of you guys had difficulty with the second equation, and I wanted to just talk through the answers for part of ISS 1.3. Um, the most important thing that I want you guys to always think about is the let statement and what the variables represent. So in this case, A is the number of adult tickets or memberships, and S is the number of student memberships. And the first question was asking you to make an equation for $400 total when it's $10 per adult ticket and $5 per student ticket. Okay. I did have this equation in your Google document too, so you guys all had it. But just keep in mind what this actually means. Um, since A is the number of adult tickets, when you multiply this by 10, like for example, just think about if you have 3 adults. When you do 3 times 10, isn't this going to tell you how much you spent on adults? So this is amount for adult. And same exact idea, if I multiply S to 5, say that you have 10 students, 10 times 5, so $50 would be how much you spent on the students. So this is going to result in amount for students, right? The reason why we're making an equation like that is because to make $400 total for membership, if you add the amount for the adults and the amount for students all together, you're going to get $400. Okay, before I do A2, I'm going to jump to A3. And A3 was asking about making an equation for 50 total memberships. Now, for every single one of you that sent me the Desmos, I did comment on it telling you what the correct answer should be. But if you think about the equation, it's going to add up to 50. And I'm talking about total number of memberships. So going back to the variables, A means the number of adults and S means number of students. So you don't even have to multiply the 10. I can say, well, however many adults and however many students together adds up to 50. So here's your first equation that you should have put into Desmo, and here's your second equation that you should have put into Desmos. Okay. Now, as far as question A2, when it's asking for at least 3 sets of variables, you're using A and S instead of X's and Y's, which basically the same exact thing, right? And I had given you a bunch of different options. So, for example, I'm not going to show you every single example, but say that you have 0 adults. Wouldn't that mean that if I give you 0 adults, I'd have 10 times 0 plus 5 times S is equal to 400. In other words, you're not spending any money on adults. So if it's $5 per person for each student, you would divide by 400 by 5 on both sides of the equation and use pouches and coins to find out that the S value would be 80. In other words, if you have no adults and 80 students, that's one pair of coordinates that would give you $400 total. Okay, so all of this work is for this one right here. If I were to do, let's say, 10, if I had 10 adults, that means that $10 per person for 10 adults plus 5S is equal to 400. So you're again solving pouches and coins here, saying that, well, so far you spent $100 on adults. Right? Simplify the equation first. So if you spend $100 on adults so far and your goal is to isolate the S, subtract 100 from both sides of the equation, meaning since you already spent $100, between the students you're going to have $300 to spend, and at $5 a person, divide by 5 on both sides of the equation to find out that S in this scenario would be 60 people. Okay. Another set of coordinates is if you have 10 adults and 60 students, your total amount is going to be 400. Okay. So since everybody had the option to pick any 3, and I gave you the options of in increments of 10, just so you know, the answers could be 20, 40. 20 adults and 40 students will equal $400. 30 adults and 20 students could also work. And if you use 40 adults would spend all $400, so that'll leave you with 0 numbers of students. Okay, so any of these coordinate points would have worked for A2. Okay. On the other hand, for A4, you're still doing the same exact thing again, because CMP3 programs tend to kind of repeat the same questions, but we're repeating the same questions with a different equation now. So you're saying, well, let's say I have 0 adults. If the adults and students adds up to 50, that means that I had 50 students, right? So 0, 50 is another set of coordinates. You can also have 10, 40. That'll add up to 50 students. You can have 20 and 30. That'll add up to 50 memberships. 30, 20 would also work. And 40, 10 would also work. Actually, even 50 adults and no students would also work too. Okay. Now, in A5, they're saying, are there any pairs of values of A and S that satisfy both equations? So if you look at the graph here, if you look at 30, 20 and 30, 20 right here, they match. So this is your answer for number 5. And your answer would be 30, 20, meaning if you have 30 adults and 20 students, you will have $400 in the income, as well as 50 people total. So you're basically looking for a point that's going to make both equations true. Now, since I'm not going to jump back and forth with decimals, I'm going to show you my book. And for part B, when you graph both of those equations into the Desmos calculator, and the reason why we've been working on switching back and forth with slope intercept and standard is because, like most of you guys said with the graded classwork, slope intercept is easier. The good thing about Desmos is you can actually plug it in standard form and you'll be able to see the graph for both of them. You don't have to put it into slope intercept form. And if you kind of look at the coordinate where this overlaps, this is actually the point 30, 20, the same exact answer as what we just talked about. In other words, this equation is going to tell me how much the $400 income is. This equation is going to tell me if it's a 50 people total. So for both of those situations to work, it has to be that point that's intersecting. So your answer is going to be 30, 20. Okay. Now, for part C, I'm not going to graph everything for you, but I kind of just want you to get the idea of it. Okay. And we're actually going to be learning how to do all of this algebraically, but when you plugged in both equations for question number 1, the point of intersection should have been at 3, 1. And when you graph both of question number 2, your solution should have been intersecting at 1, -3. And the reason why I said how is question number 3 and question number 4 weird is because when you, here, let me start with 4. When you graph this is actually going to end up being 2 lines that are parallel to each other. Now, we have solved equations before that we're going to actually revisit in investigation 2, where you didn't have a solution. Now, if you're looking for a point of intersection and the 2 lines happen to be parallel to each other and they're never going to intersect, and the point of intersection is your solution, you're never going to have a solution. On the other hand, for question number 3, if you were to graph both of them, both lines actually end up being the same exact line on top of each other. In other words, this point is a point of intersection, this point, this point, this point. Every single point on either one of the line is the point of intersection, leaving you with the solution, all reals. So just keep those exceptions in mind when we're talking about investigation 2 when we start to solve it algebraically. Okay? Hope that helps. I'll see you guys soon.